So our I can statement, I can create an equation using side measurements and perimeter. Real quickly, who can remind us when we say perimeter, what does that mean we are doing? When we're talking about perimeter of something, we are doing what? Will? Adding what? All the sides, right? We're going to add all the sides. So if I'm talking about a rectangle has how many sides? 4. So I should have 4 problems or 4 expressions that I am adding together to equal my perimeter. Okay, so when we were doing our expressions unit, we always just created the expression, but we never actually solved for the variable. Now we can solve for the variable by stating, hey, our perimeter is equal to something. So when I'm looking here at my shape, I have a measurement that is x plus 6. I have a measurement on the right side that is x. I have a measurement up at the very top that is x plus 6. And I have a measurement here on the very left side that is x plus 6. So they are all written here, which means when I am working this problem out, I am adding all 4 of these measurements together, all 4 of these sides together. So that means I've got x plus 6 that I'm going to write down here, plus, so I just did this side. I'm going to go ahead and check it off. I just used that one. I now need to use my pink side, x. Okay, I just used that one, plus my next side, my green side, that was an x plus 6. Plus, I have one more side left to do, which is my orange side. That's an x. Okay, so I've accounted for all 4 sides, and I'm going to set it equal to the perimeter. What was the perimeter in this problem? 24, right? It says perimeter equals 24. So I've now created my equation. Now I know I put parentheses around here, which means there's distributive property, but I'm only distributing a positive 1. So is that going to change anything if it's a positive 1? No. So I can go ahead and just rewrite x plus 6 plus x plus x plus 6 plus x without my parentheses. I can just write those all like normal. So that's what I'm going to do. No more parentheses, x plus 6 plus x plus 6 plus x, and that's equal to 24. Okay? So I got rid of all my distributive property. Next thing I need to check, do I have like terms? Are there like terms in this problem, Phoenix?
There are actually 2. 6 plus 6 is 12.
Okay.
4 x's.
All right, good. So we have several like terms, right? We have our x's. Right, we have, and like Phoenix said, we have 4 x's and they're all positive, so we can combine all 4 of those nicely together, right? X plus x plus x plus x, and that's going to give us 4x. And then as he said, we also have those 6's, and they're all positive 6's, so positive 6 and this positive 6 that we can combine together. And like he said, this is going to equal 12. Positive 12, so I have to put that plus sign. And that whole thing is now set equal to 24. So I can now solve for x. Before we couldn't solve for x because we didn't have an equals, but now we've got an equals. So we can actually solve for x. What is the first inverse operation that we're going to perform, Santonio? So, minus 12, yeah. We're going to subtract 12 from both sides of our equal sign. We are going to subtract the 12 from both sides of that equal sign. Okay, so that's going to leave us with 4x is now equal to 12, because 24 minus 12 is 12. What is our last step going to be? Christian? Yep, divide 4 by 4 and 12 by 4. Yeah, we're going to divide the 4 by the 4, and we're going to divide 12 by 4, and we'll get that x is equal to 3. Okay, Okay, so knowing that x is equal to 3, I can pop right on over here and I can now tell you what each of these measurements are going to be. If I were to redraw this rectangle off to the side, who can tell me what is this bottom measurement going to be equal to? If I know x is equal to 3, then what is this blue measurement here? Amara? 9. Because if we just do 3 plus 6, we'll get 9. So this bottom measurement here is 9. What about the pink measurement? What is the pink measurement going to be, Jordan? 3, because it's just x. And we just solved for x. We know x is equal to 3. What about the green measurement, the top measurement? What is that, Brian? 9 as well, which makes sense. It should be 9 because they are identical to each other. And then what does that make the orange side, Bubba? 3, because again, they are identical to each other. Okay, so knowing what our value of x is, we can use it to solve for the missing sides, to tell us what every side is equal to. And guys, if you double check, 9 plus 3 plus 9 plus 3 is going to give you 24. All right, let's try another one. Problem number 2. For problem number 2, again, I'm going to go ahead and highlight my sides. I'm going to highlight my bottom side here. I'm going to highlight the right side in pink. I'm going to highlight the top side in my green. I'm going to highlight the left side in my orange. And now the problem is with this one, there's something different about it than this one. What's different about it, Damien? Very good. It doesn't have the x plus 12 written on the bottom, but can I write it? Yeah. I know it's the same because remember, top and bottom, since they're rectangles, top and bottom are equal to each other. So if the top was x plus 12, then the bottom is also x plus 12. And then just like Damien said, he says the orange side, the left side, also needs to be an x because the left and right sides are equal to each other. They are identical to each other. So we're going to put an x over here. Okay, so now I can go ahead and set up my equation. I have my first side, my blue side, x plus 12. I'm going to cross that one off or check mark that off. And I'm going to add it with the pink side, which was x. So I can check mark that one off. And then I'm going to add it with the green side, which was x plus 12. I can check mark that one off. And then we'll add with our orange side, which was x. I can check mark that one off. And what is it going to all be set equal to? 56, right? It says perimeter is 56. So we're going to set it equal to 56. All right. Same thing again. If I distribute, I'm just distributing a 1. Is it going to change anything? Nope. So it's just going to leave it as x plus 12 plus x plus x plus 12 plus x, and that's equal to 56. All right, we distributed. Now we combine like terms. What are the like terms that we can combine in this one? Bubba? Okay, all the x's, and they're all positive, right? We have positive x, positive x, positive x, positive x. When we combine those together, what is it going to be? Positive 4x, right? X plus x plus x plus x. That's just going to be a positive 4x. Okay, what else can we combine together here? Christian? The 12 and the 12, right? And they're both positive. Positive 12, positive 12. We can combine those together. That's a positive 24. And it's set equal to 56. Okay, what do I do first? Phoenix?
Do minus the 24 minus 56.
Wrong order. Minus 24 from 56. So 56 minus 24.
Sorry.
That's okay.
Okay.
We're going to do 56 minus the 24, right? We're subtracting 24 from both sides. So we're going to get 4x is now equal to 32. 4x is equal to 32. And in our last step, what's our last step for solving this one? Christian? Yeah, but 32 divided by 4. Say it in the correct order, okay? 32 divided by 4. And then, like you said, x is going to be equal to 8. Okay, so I know what x is equal to. So now let's go ahead and redraw my rectangle so I can label all my sides. Who wants to tell me the blue side, which is on the bottom, what is that going to equal? Jordan? 20, right? Because we're going to do 8. We're going to do 8 plus the 12. So that's going to equal 20. What about my pink side? What is the pink side going to be equal to here? Ethan, what's the pink side? Pink side's labeled X. So what is that going to equal? 8. Good. So we've got 8 here, right? We just substituted X in for 8. What is the green side, Christian? 20. Oh, I'm so, I was thinking I was calling on CJ and I was going, why isn't he answering? I'm so sorry, buddy. Okay, and then CJ, what is the orange side? 8. There we go. Okay, so we have 20, 8, 20, and 8. And guys, if we add all those together, it will equal 56. Okay, it's important to know that you're not just solving for X, but you also want to know what each of the sides are labeled. Because sometimes the question will just say, hey, what is X? Sometimes the question will say, hey, what was the length? Or what was the width? And so then you would have to come back, plug them in, and tell us what the length or the width was. All right, let's take a look here. Ashley had a rectangular yard that she wanted to fence in and needs to know how much fencing she's going to need. So fencing is a perimeter. The length of one side was 3x plus 9. And the width is 2x minus 15. So if the perimeter is 19 feet, then what's the value of x? Okay, first things first, what do you think I might want to do with a problem like this to help me a little bit more? Draw a rectangle, right? Drawing a rectangle is really helpful. Okay, drawing the rectangle is really helpful. Now, they said the length of one side is 3x plus 9. So I'm going to go ahead and just let my blue side be my length. So there's 3x plus 9. Okay, and then it says that the width is 2x minus 15. So I'm going to go ahead and let the right side be 2x minus 15. But that's the only information that he told me. They only told me length and width. I wish I could finish labeling this. How do I finish labeling it? What am I going to do for that green side? What am I going to write? Christian? I mean, not Christian, CJ. 3x plus 9. Christian's like, I'm ready, though. If you want to call me, I'm ready. 3x plus 9. Because the bottom was 3x plus 9. That means that the top is also 3x plus 9. Okay? I really want to label that orange side as well. Damien, what's my orange side? 2x minus 15, right? It doesn't matter that they only gave me 2 measurements. I can go ahead, draw the rectangle, and I know my rectangle is the same for top and bottom, and it's the same for left and right. Okay, so now we can go ahead and identify how to set it up for the perimeter. So our equation is going to be 3x plus 9, so we worked with that one, plus, we got our pink side now, 2x minus 15, plus, let's do our green side, 3x plus 9. We're going to do our orange side, 2x minus 15. And the whole thing is set equal to what? What did they say the perimeter was in the problem? Jada? 19, right? They said perimeter is 19. Perimeter is 19, so we're going to go ahead and put 19. All right, so when we distribute, we're distributing a positive 1. Does anything change? Nope. When you distribute a positive 1, nothing changes. Okay, so we're just going to write it. We're just going to get rid of those parentheses then. 3x plus 9 plus 2x minus 15. plus 3x plus 9 plus 2x minus 15. And it's all equal to 19. Okay, it's a nice thing about distributing with positive ones. Nothing is really changing. Okay, what's next? What do we have to do now? We distributed. What's next to do? What are we going to do? Jordan. Good. We're going to add 3x plus 2x plus 3x plus 2x, right? Those are my like terms for my variables. I've got 3x plus 2x plus 3x plus 2x. And when I add those together, guys, what are we going to get? What's 3 plus 2? Yeah, 10, right? 3 plus 2 plus 3 plus 2, that's 10. So we get 10x. Okay, tell me next. What am I doing now? Corey? Good. Plus 9 minus 15 plus 9 minus 15. So we have a positive 9 and negative 15, positive 9, negative 15. We can combine those all together. And what will that give us? Negative 12. Good. So we'll have negative 12. And the whole thing is still equal to 19. That whole problem is still set equal to 19. All right, let's start solving. Jada? Oh, well, why don't you tell me the next step to do?
After that, we do
Uh-huh. Yep, plus 12. There you go. Yep, exactly. We're going to add 12 so that we can get rid of it here. And we're going to add 12 on this side. Okay, so that's going to give us 10x is now equal to 31. Okay, what's next? Amara? Divide it by 10. Very good. Divide it by 10 on both sides. Oh no, I got a decimal. Does that mean I got it wrong? No. Decimals are still answers. X is equal to 3.1. Now, again, if they want to know what are the measurements for the length, if they wanted to know the measurements for the length, what color did I do length in? It says it right here. Length is this value. What colors did I use? Liliana? Blue and green. So it doesn't matter which one I decide to do, blue or green, it's still the same. So I'm going to use it here. I know that my length was 3x plus 9. So instead of 3 times x plus 9, we're going to do 3 times 3.1 plus 9. For my length, we're going to do 3 times 3.1 plus 9. What is that going to equal? Do that right now in your calculators. You've got your calculators to do 3 times 3.1 plus 9. What is that going to give us? Christian? 18.3. Good. So our length is equal to 18.3. All right, let's do our width. Again, our width is the other measurement. The width was 2x minus 15. So we're going to do 2 times our x. What was our x again? Our x was 3.1. So we're going to do 2 times 3.1 minus 15. Okay, so what is 2 times 3.1 minus the 15? What do we get? Corey?
Negative 8.8.
Negative 8.8. Now in real life, we won't set it up like that. Negative 8.8 for our width. We won't ever have a negative number for our width or a negative number for our length, but it just happened to be that problem did that. But you want to make sure you know how to identify your width and your length. All right, let's take a look at problem number 4. I know it doesn't say rectangle, but we're going to say it is a rectangle. We have a rectangular rug. We got a rectangular rug. The perimeter of the rug is 119. The length of the rug was 21.5. We want to know the width of the rug. So here I'm going to put my little colors on again. I have my blue. Here's my pink. Here's my green. Here's my orange. Okay, does it matter which color I label my length?
Yes.
No.
Not really. I might say, hey, blue's my length, or maybe my pink's my length. But if I choose blue to be my length, then so does green, right? If I choose pink to be my length, then so is orange. Okay, so it doesn't matter which one's really your length, as long as you label one of them. Okay, so I'm going to go ahead and label my length in blue. So that's 21.5 for the blue, which means that green is also 21.5. Now it says, what is the width? Did they tell me a measurement for width in the problem? No, they didn't tell me any measurements. So when we don't know, what do we put? An X. So for pink, we're going to put X. For orange, we're going to put X. Okay, so let's write it out. We have 21.5 plus X plus 21.5 plus X again. And then it's equal to what? What is the whole perimeter equal to? 119. Okay, we don't have any distributive property this time because we only had single terms for each of our sides. So we didn't have to do distributive property. But we do have like terms. What like terms can we add? X and X, right? We have X and we have X. We can add those together. What's X plus X? 2X. What else can we combine? Good. 21.5 and 21.5. What do we get when we do 21.5 plus 21.5? 43. Good. And the whole thing is set equal to 119. All right, now let's start solving. Santonio, what are we going to do first?
We're going to subtract 43.
Good. We're going to subtract that 43 from both sides. That's going to give us 2x is now equal to 76. Okay, 2x is equal to 76. All right, Liliana, what are we going to do now? We've got 2x is equal to 76. We need to get x by itself.
I know, but like that's why I did that because we're gonna divide.
There you go. I was like, wait, she gave me the air quotations, though. I like that. That was good. We're timesing. When we're really not timesing, we're dividing. Good. All right, so we're going to get x is equal to 38. Okay, so x is equal to 38. So what's our width? Our width is 38, right? X is equal to 38, so our width is equal to 38. Okay. You guys have, in a moment, you're going to have a way ground. It's only 7 questions. You have redemption on it as well, so if you don't get something right, you can try it again.